All right, how is it going, Robo fans? Thank you to everyone that is eventually going to join us here. Appreciate you guys coming in. This is, I believe, number 5 on the live interviews that we're doing. So I've been doing these every week, talking to amazing people using our products and hopefully giving you guys inspiration at home, whether you're using our 3D printers or using other 3D printers or just interested in the technology. You can learn from people that are actually using in real life applications and see some of the amazing stuff that we're printing. So today, we have a special, actually a group, First Team Robotics, Team 4216. They're called Team Hephaestus. They'll tell you a little bit about their story. They have been doing this for 8 years, competing in the first robotics challenges, and these kids work extremely hard. They actually came down to the office and showed us their robotic stuff that they're building, and it's just amazing. They're the bots that they build to compete. So I'm going to bring them in. We're going to talk a little bit about their team, how long they've been doing it, some of their experiences, how they use 3D printing to build the robots, and just the whole process through that. So without further ado, I'm going to bring in my 2 guests who are going to be speaking on behalf of Team Hephaestus. Let's bring them in. What is going on, guys? How you doing?
Good.
Great.
And first off, introduce yourselves. Who are you? Tell us just a little bit about the robotics team, and also tell us where you are right now. It looks like you're in a mad garage there, just doing crazy things.
So yeah, I am Sarah Thompson, and I'm pretty much the lead 3D modeler on the team, and we are in our mentor's garage.
Nice, I love it.
Yeah, so I'm Casey. I'm one of the team captains on my team. Sadly, my co-captain isn't here right now. But
that's all good. We'll get him in on the next interview.
Yeah, maybe, hopefully. Yeah, but we've been a team for actually 8 years. And just last year, the original members graduated and they're off all going to college. So that was a very great year for us. And that was just so happened to be the year we actually won Worlds and moved on all the way to Festival of Champions. And so that was a really great year for us. And it's really going to be hard for us to improve this year.
Yeah, so for everyone that's watching, gonna see this on YouTube later. This team right here is actually a world-winning team, right? They competed in what's called the Festival of Champions, which is pretty much the highest level of competition for First Team. So, and you guys actually won last year, which is absolutely incredible. And so you guys have huge credibility, you know, obviously the award for that in the market. And I'm sure a lot of teams are like looking up to you guys as sort of like leading this space now. Is that kind of how it is?
Yeah, in our region, we try to get and help out as many teams as possible. So we hand out business cards and give teams our contact information. So whenever they need help, we can just provide it with them. And we get a lot of emails. I just saw one like a couple hours ago when I was emailing with you.
People asking to asking for advice, how to build the equipment, all that stuff.
Yeah. We love just helping out teams and learning new things from them as well. And it's a really great community because it like encourages cooperation and sharing ideas, and stuff like that.
So this is a high school. You guys are a high school team, right? That's what First Team mainly is. Is it all high school or is it younger as well?
Some teams have people that are in 7th grade all the way to 12th grade.
Okay, cool. So have you guys been doing this for how long? You specifically, 3 or 4 years?
This is my 4th year on the team.
4th year, okay. So you're going to be leaving next year. As long as you graduate, you don't pull a Van Wilder.
This is actually my first year on First, but I'm also a junior. So okay,
cool. Nice.
Yeah, we're juniors, so we have one more year after this one.
So this has been going on for 8 years, this team. You guys are kind of carrying the legacy from last year, which obviously big shoes to fill. It's you guys won the Festival of Champions, which is a massive honor for anyone that's watching and knows anything about First Team Robotics. So they kind of schooled me on it when they came down, when First Team came down to the Robo offices and showed us their robot. And I got to realize actually how big that is, which is incredible. And the coolest thing that drove me to it is that you guys actually improve on your robots using 3D printing, obviously. So when kind of diving into a little bit about 3D printing stuff, when did you all first start using 3D printing?
So our team actually got a very first 3D printer about 3 years ago when they actually started allowing 3D printed materials and parts to be placed on your robot. And
so before that, you couldn't use any 3D printed stuff.
Right.
Okay.
And so when they recently started allowing it, they have actually a competition that we can enter to write an essay and actually win one. And we were just so fortunate enough to be one of those selected. And
Nice.
so that's how we got our very first team printer. And we had people that started learning CAD from that and going on from there. And it was a really great learning experience for us.
What CAD program were you guys, did you guys pretty much, so you were able to use 3D printers in your actual robot design. Did you have any experience before that? Or are you guys like, okay, now that we can use 3D printing, we got to learn how to do 3D modeling, and we had to learn how to 3D print, and we have to get a 3D printer? Is that kind of how it worked?
Well, one of the very first people that started learning 3D printing is gone now. So I can't tell you exactly how he got into it.
Yeah.
But I can tell you that he was using Google SketchUp.
Okay.
For those of you who may not know, isn't as engineering per se.
Yeah, most definitely. It's a pretty basic, it's a free software from Google, obviously, where you can go on and do 3D modeling. So I think a lot of people, it's one of the main uses for it is in like architectural modeling.
Right.
So yeah, it's not extremely engineering friendly, but it's a simple software to use. So that's pretty cool. And then did they start sort of, so they, maybe he learned 3D modeling first, and then he start kind of like passing it on and teaching the other person, and it sort of just kept staying with you guys, the 3D modeling, or did you have to pick it up from scratch?
Actually, I believe how that started was we were fortunate enough to have a school that offers an engineering program, and one of the very first classes is a 3D modeling course.
Nice. Okay.
So throughout the years, there are a few kids on the team that have taken that course, and slowly that started getting integrated into the team. And
so how's the team split up? Is there someone that's like you do the 3D modeling, correct?
For the most part, there's people make other models, and when needed,
so you all have your own part. You're all like a leg and the actual team that makes it all work.
Yeah, we have multiple members that do multiple parts as well. So they help out supporting in a lot of areas as well. So we can have very fundamental members that are crucial to the team.
So what do you think was the reason? I'm curious, and hopefully other people are too that are going to watch this, is what do you think was the key ingredients, the secret sauce to having a world-winning team? Like you guys did you guys are the top of the top here. Last year you guys did an incredible job. You won this massive competition. Like, what do you have any thoughts on what you guys was maybe your edge over everyone else?
Well, for one part, we did have a lot of experience, so that obviously did help us. But one thing I could say was trying to keep the robot as simple as possible at first, and then trying to improve upon that. Okay. So yeah, we did that this year, and we actually started doing really well at our competitions. But when we created a new robot and complicated things a lot more with the second version, it actually started working less reliably, and so now we need to create it and
start simple, something basic, add on to it the features that you need to actually have it perform better, right?
Yeah, it's all about reliability.
Yeah, most definitely. So, and the way First Team works, correct me if I'm wrong, you guys obviously know this way better, is every year there's a new competition, I guess, if you will. It's not, there's a new like challenge that your robot has to perform for the most part. Is that how it works?
Yeah.
So you're constantly iterating. It's not like you could use the same robot from last year, go compete again, and win the world champions again. It's a new challenge that you have to compete and win. So I'm sure like when you guys you have a new challenge of designing a new robot, like you're using the 3D printing and the 3D modeling to design stuff to make it perform better, and then scrapping it and designing new stuff and just going through that. How many times do you think you go through that process? A lot, right? Yeah.
So it doesn't happen as much where we take apart the whole robot.
We've already done that once this season.
Yeah, but what we'll do is we'll focus on subsystems, and if a certain subsystem in a robot, like the intake isn't working, we'll completely take it apart and try to fix that up and just figure out what's going wrong and fix it.
Okay, cool. And you guys, would you say, I guess looking at the 3D print or the robot that you guys have built, how much of it do you think is actually 3D printed? It's probably, because you brought it in and you showed it. It was not a ton, but it was a lot of significant parts, if you will, were actually 3D printed.
So there's our old robot for the last season had a lot 3D printed, as well as this new one. One of our main parts of this is to, what part was that? Grab or to flip over our intake for the cubes. Okay. So to do that, we actually 3D printed this piece.
Oh, sweet. Okay.
So that is a major part of the robot that we've used.
And what is that piece? What's the functionality of that? Right. So this is a part on a robot that we use as an arm. So what we have is actually a plate that goes on top of this, and which holds the glyphs and the boxes that we will eventually use this as an arm to flip and as basically our pivot point. And it's on two servos, and we have a lot of weight on it, so it has to support a lot of weight. And so we had to learn a lot of printing techniques to make sure it's really strong and sturdy so it doesn't break.
What material are you using mainly? Is that a PLA plastic?
Yeah, actually so far we've basically only used PLA. We're planning on using flexible more soon, and hopefully working with ABS. But what we work on the robots that hasn't been necessary yet.
Yeah, cool. Okay, yeah, and there's Color Fab. Like some of these companies have some amazing like high strength PLAs and stuff. If you get into needing more of that strength, I know there's like certain guidelines that you have to abide by when you're building these machines, but there's some cool stuff out there. So we'll obviously share that with you as we get some. Let's just dive in to the actual machine, because when you guys brought it in, I had seen stuff before. We'd been to a robotics competition, but when you brought it into the Robo office and actually saw it, I started to realize how complex these devices actually are. And it's funny when you say it started out simple, because I look at them and I'm like, how does this thing even start out simple? Because it just looks so complex and amazing. So it's cool to see that and understand that it did start from like a small, simple spot and grew into this amazing, robust machine. So let's dive into it. You can grab the computer, show it. Let's talk about it. Let's show some 3D printed parts.
So I'll try to do my best here, but this is our robot from last year. For those of you who may not know, the goal of last year's challenge was mainly to intake wiffle balls.
Yep.
And shoot them into this basket on top, and that's how you mainly score points. And so, these are a couple of one of the wiffle balls from last year that we used that are actually in this year's competition. Yeah. So we have actually a really simple intake that works really reliably. We just have a simple spinning axle here, which runs with a lot of zip ties on it, so we can intake the ball. Okay. And so after that, we actually have it going up to a conveyor, but since it's a lot more confined, we actually need to 3D print a piece in there. You can't see it because it's really black, but we have two pieces on each side, one on each side of the funnel, and so we're actually able to funnel the balls in and keep them really nice and straight in there to improve our consistency.
Cool. And then what other components on there are printed? Is that pretty much it?
No.
We have a lot more parts, so it's going to be hard to show you guys.
It's hard. Are you able to set, is there somewhere to set the computer on? Just like a flat surface?
We're running off of a camera that's hooked up to a wire. So
okay. No problem. Just keep it going.
Yeah, okay.
You're doing good.
So we have a lot of supports for electronics too that are 3D printed. Okay. There are a lot of custom pieces, and so they make sure all the wires are secure. So if you want to bring the robot closer.
What's the typical time it takes? I mean, you guys work on this over how long of a period of time and how many hours, just so everyone understands how long and like how much effort and how much hard work you guys put into these devices. What's that like?
So was it last season we predicted 5,000 hours went into this robot? Yeah, so
over what period of time did you cram all that in?
The season starts in September when school starts, And so depending on how long the competition goes, you can either end around February, is it?
Okay.
Win a league
Yeah.
championship. And
Yeah.
but if you get lucky enough to move on to further levels, you keep on advancing. And we actually wound up going to a competition in the summer. So that was almost a whole year for us, and that occupied a lot of time. And so during that time, we got a lot more time in to make a lot of modifications to our robot and keep on fine-tuning it.
Does it get damaged in competition? You have to 3D print like solutions to fix it on the spot?
Luckily, we haven't had any major pieces break, but what we have done is we've broken some 3D printed parts, and so we have to use glue to glue them out together. The funnel that I was just talking about earlier, we didn't 3D print it thick enough, so what happened was it just broke when a ball tried to go in there, and it got forced in, and the force that was applied to it just wound up snapping it.
Yeah.
I mean,
cool.
This piece that we were showing you earlier, this is a spare one because our mentor literally said, I bet you if anything breaks, it's going to be this just to spite us. So we have an extra. So we're trying to do more of that so that we have a replacement just in case.
Bring mission critical pieces. I like it.
Yeah. And for competitions like the one in Phoenix, we actually will be bringing our C2.
Cool,
so we can show others and the community and print.
Oh, there you go.
We have little medallions.
So you guys have mainly been using the R1 before that. Then we got you the C2. So now you guys are using that. Eventually you'll probably have an R2 up there, and you'll be printing all sorts of crazy stuff. So, and hopefully Robo will help you with your legacy here with the robotics team. Keep winning some amazing competitions. I mean, regardless, I mean, for people that are watching, that wondering, I mean, we've all heard about robotics competitions at First Team Robotics, but it's sort of unfathomable when you say it's taken 5,000 hours to build these robots. That's incredible. I mean, they say it takes 10,000 hours to become an expert at something. You guys are putting half that in one season building a robot, which is just incredible. I mean, you guys know the ins, outs, and everything about these things, don't you?
Yeah.
I mean, all members of you guys, I'm sure, have to participate.
Yeah, we all learn a lot throughout the season. It's a continuous learning process for all of us, as we just go throughout the season and see designs from other teams, and maybe we're able to incorporate something with them, and maybe teams will see something for us, and we're able to teach them something from that.
Yeah, definitely. So where do you guys see? I mean, now that 3 years ago, 3D printing was actually integrated as acceptable to be in the program, do you see this being used more in building in the future? Do you see using maybe like different, right now you guys are using our FDM technology. Do you guys think you're going to get into other technologies as you move forward? What are you guys looking for in 3D printing?
Honestly, I would say probably more of this, and hopefully as the technology grows, maybe we'll be able to 3D print metal versions or things like that. Because I know actually earlier our mentor was saying, oh, this part works really well. We might want to get that fabricated in metal. So, I mean,
we are
technology.
I'm testing some cool steel filament right here.
That's awesome.
So this is gonna be pretty cool. It's by Virtual Foundry, so this is gonna be a really cool material that hopefully we'll start reselling here in the near future. Let people print in like this steel infused plastic. It's actually really highly dense steel inside the plastic material, so you'll probably get a lot of strength properties from it and things like that. So we're gonna do a lot of that testing, and hopefully we'll be able to get you some good stuff there. But yeah, how much of the robot is actual metal? Is it mainly metal and 3D printed components, and obviously electronics?
Yeah.
Yeah. So
most like plexiglass and.
Yeah. So most of the frame is metal. We used a lot of 80/20 last year and some Tetrix parts.
Yep.
But then we also use some plastic parts as sheets just to protect a lot of the electronics and basically fragile parts of the robot.
Yeah.
And then, so a lot of the electronics in here are, like I said earlier, supported by 3D printed parts. But then
you guys are programming all the electronics. You're building everything from scratch. You're designing the 3D printed components and assembling it within the build. What else? What else goes into building this machine?
So the only thing that is standard we don't have to do is create the electronics, but everything else, including programming, which the robot has to run for a 30-second period at the beginning of a match where you can't drive it at all, so it has to have all these sensors on it. Like here, we actually have a color sensor with a 3D printed lid that helps shade it.
Oh, cool.
So what we actually were able to do is use this to read a color on a beacon, and so it either display a red light or a blue light, and so we had to use this to detect which one it was, and so we pressed the right beacon, hopefully. And so that wound up being a really successful part of our robot last year.
How do you find like that device right there? How did you figure out how to make that? Like, where did you start when you're like, hey, like we need to be able to detect the different colors, this and that. We need to sensor. Like, where did you start? And the reason why I'm asking you is because it's very similar. A lot of people ask us because, you know, we don't have like massive engineering backgrounds when we started our business. A lot of people are like, how did you guys build this company that's like in a high-tech environment? I was like, we just went online and we learned. We just looked at videos. So is that similar to what you guys did?
Yeah, so a lot of it is just research.
Yeah.
And so you have to, it's part of the design process, which we try to follow at least.
Yeah.
We just get as many concepts as we can down and get as many ideas as we can and just try to pick the ones that will hopefully work the best. And if you get lucky enough, it will. And be as lucky enough as we were last season.
Yeah. Do you guys are you able to carry some of the technology that you build into the new model for even though it's a new challenge, does some of that become reusable?
Yeah. So one thing that we actually are trying to reuse this year are these 3D printed caps at the end of these 3D printed slides. So,
cool.
Yeah. So, sorry, they're not 3D printed slides, but this was actually a very successful part of our robot last year as we use it to cap the ball. There's a really big yoga ball that sits on it, and we have to lift it up. So this will extend. But these 3D printed parts enabled us to do was make sure that the strings and the lines that lifted it were actually secured and they wouldn't fall off the pulleys that they were on. So it would basically make it a lot more reliable, and it would just create this machine that would just allow us to eventually win. So.
Yeah, it's incredible. I got to get some pictures from you guys after this so I could post it on the comments on the Facebook stuff, because I just want people to get like a really solid visual of what this thing looks like and how complex it is. It's just, I mean, like I said, I was just blown away when you guys brought it into the office. And I know this is a newer model. You guys are competing tomorrow, correct?
Saturday, yeah.
Oh, okay, so I'm interrupting you in the middle of your prepping to do a live interview, but hopefully people, that ended up watching this, we like to share it obviously with groups of people that actually are in similar areas. Maybe they're kids that are in First Robotics team type stuff and they're interested in learning more. So what would you say, like, I know you guys talk to a lot of kids. What would you say to anyone that wants to get into building robotics?
So depending on what age you are, there's a lot of different programs that First offers. So for instance, if you just go on firstinspires.org, they have 4 programs right now. There's First Lego Challenge for Juniors, or not First Lego Challenge Junior, and it's really little kids, and it's really great for them to get experience at a really young age. I forget exactly how young they are, but Sarah, do you know?
I want to say 9.
Okay.
Yeah, so it's really great for kids to get experience when they're younger, and then they can move all the way up the 4 programs until FRC, which is actually a bigger competition than what we're in right now.
Yeah, cool. Yeah, it's pretty awesome. And what I talk to, I don't know, when I think about 3D printing as a whole, right? I say, hey, we have this tool where, kids, adults, anyone can actually build something from scratch. But I think when you're talking about like kids, especially younger, all the way through high school and even into college, what I get excited about is that it's actually changing the way you think.
Right.
When you realize like, oh, I just built this from scratch, then you go out into the world and you start looking at things and you're like, oh, like this could be way better. I'm going to build it from scratch and like make it better, right? Have you guys started experiencing that as you're kind of like just living in the world you live in?
Yeah. I can't point to any specific examples, but you definitely do. And I may have not thought about this much before, but you definitely do start noticing just like little details that someone eventually had to design, and then you start thinking of ways to improve it.
Yeah, it's super like empowering and confident for you guys. Like when you go, I feel like when any challenge is presented, whether it's like you need to solve this problem or come up with a solution, whatever it may be, you guys like have kind of this mindset where you go, okay, we've done this before. We've learned how to build something. We've learned how to design. We've learned how to 3D print. And so it's just pretty cool kind of seeing these kids evolve from a young age. And I think First Team and what you guys are doing is really like one of those big, participants in helping change that mindset shift. So it's cool.
Yeah, it really gives us a really big opportunity and opens up a lot of doors for us in the future. And the 3D printed technology has increased exponentially in the past couple of years, and we just really can't wait to see like what it'll allow us to do in the future.
Definitely.
Now, what technology is there? Any technologies besides 3D printing that's exciting you that you're looking at, whether it's like virtual reality, augmented reality? Is there anything that you think you're going to be using in robotics in the future?
One thing that I've gotten very interested in, but I have not been as active in it, is researching artificial intelligence. And so, yeah, robots.
I knew that was going there.
Yeah. I've been doing a lot of research, and the way it seems to be going is very interesting, and there's a lot of different opinions out there. I'll say that about how it will change the world. And
you're kind of setting yourself up to, like if that's something you're interested in, get excited in, you've kind of built this foundation for yourself to actually go out into this world now beyond college or, your next step and work in that field and start your own business, work in a company that actually looking to hire someone that's worked with robotics. So I think that's really cool too. You guys obviously have a bright future ahead of yourselves.
Yeah.
and you're part of a world champion team. Come on.
Yeah, I know, right, guys?
I know. Some say you have like 10 members and they're all like, right? Yeah, come wave on the cameras, like award-winning robotics teams here. What's up, guys? How you doing?
These are our programmers right here. They've been here. They've been programming.
The mad scientists at work.
Yeah.
Hey. So what do you guys? Is there anything that's bogging you down at this point? Like before the competition, are you guys kind of like ready to rock?
Honestly, everything is going pretty good. I mean, things usually go well the day before, and then we discover things we need to fix. But we're all pretty excited. We're just ready to get some practice in and then head over to Phoenix. So.
Work on the notebook.
Yeah.
That's what I'm doing.
Another part of the competition that's not robot related is making a notebook filled with meeting entries and outreaches and everything.
Oh, cool.
So we have to present that at this competition. Not every competition we have to, and we've kind of gotten a little behind. So that needs to get fixed before Saturday.
Oh, wow. You guys got a lot of work ahead. I'm going to let you guys get back to it. Thank you for coming on doing the interview. Thank you for thanks for talking about, everything that you're building, and congrats on your successes with the First Team Robotics. I'm going to follow your guys' journey because I know you're going to be successful beyond this. So keep doing what you're doing and inspiring people, and we'll share this. And if they have any questions, hopefully I can reach out to you guys. We can answer them, and we can put them in the comments section. And also, if you can send me some pictures of that robot so I can put them in the comments section on this video just so people can see it more in depth. That would be awesome. Cool. Well, any shout outs you want to give before? Where can people find you? Where can they learn about the team?
Shout out to our own Instagram. It's ROH4216. That's pretty much the name of all our social media accounts. We have Twitter, Facebook, Instagram. That's really the best way to look at us and see our journey, especially with building this. So
So if you want to learn more about this world champion team, follow them at, what is it? Say it one more time.
ROH4216.
ROH4216 at ROH4216, Twitter, Instagram, all that. Go check them out. Thank you guys so much for coming on. I appreciate it. I'll talk to you guys soon.
Thank you.
See you later.
Bye.
All right. Later.